So in my last video, I talked about how we are constantly surrounded by radiation and that we are actually glowing like a radioactive light bulb. But one of the things that I forgot to talk about was what specific type of radiation was I talking about? Now, there are four different terms that you should become familiar with. There's particle radiation, there's electromagnetic radiation, ionizing, and non-ionizing radiation. In my last video, I was talking specifically about ionizing radiation. It's very common for us to say radiation when we're referring to ionizing radiation, both particle and electromagnetic radiation. When I say ionizing, I mean that radiation has enough energy to come into an atom and knock off an electron. Once you knock off an electron from that atom becomes an ion. If that ion is inside your body, it can actually cause damage to the DNA in your body. So where do we draw the line between ionizing radiation and non-ionizing radiation? First off, let's talk about electromagnetic radiation. And electromagnetic radiation is purely energy in the form of electromagnetic waves. And these waves exist in a whole spectrum of energies. The faster that wave is going, the higher the energy it has. And you're probably more familiar with this electromagnetic radiation than you know. In fact, this light right here in front of me is electromagnetic radiation that exists in the visible spectrum. Once you start getting higher and higher energy past your UV, you start getting into the ionizing radiation, where around right here you have enough energy in order to knock off those electrons from the atom. At this ionizing energy, you start getting into the X-rays and gamma rays. And once you go down from the visible spectrum, you get into your infrared, into your microwaves and radio waves. At this point, you cannot cause ionization inside your cells in the same way that ionizing radiation can. And this isn't to say that radiation at these energy levels can't cause you any harm. If you have a large amount of it, like inside of a microwave, it can cause burns. But using your cell phone, that should be fine. All right, so what about particle radiation? When is it ionizing or non-ionizing? When we're talking about particle radiation, typically we're talking about alpha, beta, and neutrons. For at least alpha and beta, the difference between ionizing and non-ionizing has to do with whether or not there's any energy to them or if it's slowed down. So if a alpha particle has slowed down completely inside of a material or inside the air, it actually just simply becomes helium. In fact, that's where all of the helium on Earth comes from nuclear decay from the naturally occurring radioactive elements inside the Earth. Beta particles, after they've finished ionizing in these different materials here or inside your body, they'll slow down and they are simply electrons that are captured within the material. Neutrons, however, once they slow down, they don't necessarily stop becoming ionizing radiation. They can ionize at any energy, whether or not it's fast or slow. Once it slows down in the material, typically in water is where it slows down the most, and your body is mostly made up of water. It'll slow down and then it'll become absorbed inside of a element, and it can turn that element into a completely different element or a different isotope that is actually radioactive. So for a vast majority of the radiation, we typically say once you're no longer exposed to this radiation, you're not radioactive. So if you get an X-ray, you do not become radioactive. Neutrons, however, if you have enough of these neutrons, you can actually become radioactive yourself. Here, it doesn't mention protons, but it's similar to a neutron. If you slow down enough, it can become just simply hydrogen, but it could also be captured inside of your body or material, and it can make things radioactive as well.